Okay, I did a session on like House of Force, and the session was lengthy, and we like spent much time debugging and all that. So I thought the video would be lengthy, so I'm like making a shorter video where like if someone is like stuck somewhere, you can like jump in and watch a maybe 10 minutes video and all, you're done. So we like started with defining what GLIBC is, which stands for the GNU library and all that. So the libc like provides a boilerplate for functions for like other binaries to use those functions and all that. So instead of like having the function printf in your own code, you like just call it from libc. Since House of Force is like use malloc, the way that malloc works against itself, we will have to like look on malloc and the malloc internals. So malloc is just like it's a function whereby it's a function in libc whereby you like use it to like allocate heap memory. So this is like memory that is allocated at runtime. So basically we like want to learn malloc internals, and like when you're dealing with House of Force, we like consider the chunks most likely. So when you're talking about the chunks, it's like the fundamental unit of memory that malloc deals with. So talking of chunks, like the smallest size of a chunk should be like 24 bytes. So 24 bytes, then you add the 8 bytes of like malloc metadata. So on the metadata, it's where like malloc tells itself, yeah, the chunk size is this, is the previous chunk being used and all that. So that's the malloc metadata. So in lir sense, like the chunk, the list size of the chunk should be like x20, which is 32. So from there, the malloc now like increments the chunk with 16 bytes, that is x10. So the next chunk should be like x30, x40 and all that. So when you're like looking on the chunk and all that, there's this prev in use flag. They can be set or not set, just like tells malloc the previous chunk is set or is in use and all that. Yeah, so we are going to like focus on so-called generic heap exploitation techniques that to the greatest extent possible leverage malloc's internal operation against itself. So we want to do like a demo to like see how this value are like allocated. So let's see. Yeah, and we can see like we have like 5 malloc calls, and we can see that for the first one we are requesting for a 9 byte chunk, this we are requesting for 1 byte chunk, we are requesting for a 0 byte chunk, we are requesting for this is 24 bytes chunk, and this one will be a 25 bytes chunk. So we want to see like how malloc will like allocate that memory. So what we will do is like we'll set a breakpoint at every malloc's after every malloc's instruction, and then view the memory. So the next thing we want to do is like set a set of commands whereby we can like view the memory. So we can first run the program, and when malloc is called, you know, always the return value is like stored in the rex. So we can see that we have that. Another way we can like view the memory, so because this is the heap address that is returned by malloc, is like using info proc mappings. Yeah, and we can get this. So you can define a hook stop to like tell it what to like view after we hit a breakpoint. Yeah, and we can see that on these 2 mallocs where we like requested 1 byte and 9 bytes, we were allocated a size that is equal. So this is like 8, you add 8, that's 16, that is 24, then you add the 8 for them for mallocs like metadata, so that is hex 20, which is 32 bytes. If we continue, we are like hitting this one, we are requesting for a 0 size chunk. So malloc checks is 0 like greater than 24, no, then I'll just give you the list the least chunk size, which is 24 bytes. So if you continue, it likes checks is hex 18, which is 24 bytes greater than 24, no, and so if that is not true, it will like give us that least size of a chunk. For the next one, we will see that you are given hex 30. That means that 25 you are given hex 20 plus hex 10, which is 16 bytes. So that is hex 30, meaning that 25 is greater than 24. So yeah, the reason we are not seeing the other is like we define that we want like 20 words in the heap. Yeah, and we can see this is the value of the wilderness. So we are like allocated this, so this is 1 2 3 4 5, so 5 times 8, that's 40. Then you add the 8 for the metadata, so that's 48. Yeah, so having checked that, now we can like jump into House of Force. So House of Force is like we will like overwrite the top size chunk. The top size chunk is that value that indicates the size of the wilderness, and from there, if we overwrite that size, so we like control we can tell malloc, yeah, the size is not like this one, we overwrite it with a value that is larger than what was there. So we like tell malloc there is a larger memory that is still free, so you can like allocate that. Yeah, and we can see we can like do dynamic analysis. From here we can see that we are leaking ports and heap, because this is not like a crash course on how like we leak addresses. We want to focus on the technique that we are doing today, so that is House of Force. So basically have like this to help us achieve what we want to do. So we can see that we have one functionality for like malloc. We can say like we want 24 bytes, and then give it like A's, and then you can see that we have one chunk there. We can break out of here using like Ctrl+C. Yeah, and we can like view the heap now, and you can see that our A's are like allocated there. Yeah, our A's are like allocated there. This is the size, and then the size of the wilderness there. If we like specify 2, we are like given the target, which has this value here. So this will be like what we will first try to like overwrite. So the 3 will like just quit the process. So yeah, so the way I want to like do this, because we already know we can like overwrite the top size chunk is like using a script. So I'll just like attach GDB there, and then I have all this like helper function. Let me show you like what they do. Yeah, what that does, it's like it logs this information and like stores this in a variable. Then we like drop into an interactive prompt where we can like interact with the program. So the next thing we like want to do is we can like log also the puts value and heap value. Yeah, and we can see like this is the value of the heap, this is the value of the puts address. Exactly. So we can like continue now to do the House of Force technique. So we can declare a helper function, so we like call it malloc. So malloc will take 2 arguments, that is the size and the data. So we can like try to leverage like if this works. So okay, why I like use that is because if you launch this, we are like telling malloc to get this up to here, to like receive bytes up to here, and then we can like send 1, and then we are telling it to receive up to here and then send the size. Then if the size is 24, you are telling it to receive up to like data and then send the data, maybe something like that. So since we have a helper function now, we can try to like see if this works. Yeah, so what we want to do is like we want a 24 byte chunk, then we want to send 24 to like make the chunk full. So if we are given 24 bytes, we'll get 24 A characters there, then overwrite the wilderness value with the largest possible value in a 64-bit machine. We want to uncomment the GDB so that we can view the memory. Yeah, so like if we hit continue, we are seeing that we have one chunk of malloc, so we can like view that using like this address here. Yeah, and we can see that you have overwrote the wilderness value with like the highest possible number in machines. So like what now we are like telling malloc to do is like now this is the highest address, so I guess that is like on the stack, because the stack is the one that is like on the higher addresses. So now what you can like try to do is like make a function which we will call like distance, or calculate the distance between now where we are to like the highest address, and then wrap around on this virtual address memory. We like wrap around and then add the target address, so that if we like allocate that memory, we can like overwrite this target value. From there we can now like calculate this distance. So what you're doing here is like converting the heap to like an integer, then adding the hex to 0, the size that we like allocated first, and then now the target, where the target is, we are like subtracting a hex to 0 to like allocate up to somewhere close to where it is. So we want to like define a target variable here, something like that. Now we can like do malloc with that. Yeah, so what we are doing here, we are like because you know how Python 3 is, it complains a lot if you like send these things in a string form, so it like wants the byte form of that. Then we are like allocating just one character in all that memory. So the next malloc that we'll do, we like overwrite our target data, and I'll just like write, yeah, I have won, something like that. Then you can run the script. So we have a typo there. Hitting continue, we can like now view the target value using 2, and you can see that, yeah, I have won. So the first technique is done. The next one is like we want to drop into a shell. So yeah, so like the distance so the next thing we want to like do is a drop into a shell, and you know like how malloc works. If this underscore malloc hook is set, if you like request malloc for anything, it will first like go to where the malloc hook pointer is. Like it will first check if the malloc hook is set, and then if it is set, it will try to like go to that address and do something with it. So basically we want to like target this guy here, then set the guy to like the address of system, and then from there we like want to call malloc, and the size we want to specify it as the bin.sh thing, so that it will like be something like system, then bin.sh, yep, something like that, and this will like land us into a shell. So let's try that. So I'm just commenting out the code that I don't need. So basically using this, we like now have basically want to remove also this function here. So Yeah, so we have the distance between like the malloc, so between like where malloc hook is here and where our first chunk is. Yeah, so the next thing we need to do is like allocate that call malloc and then indicate that we want a size large like that distance. Then on like on those like first addresses we want to store bin.sh, and look at this, we are like terminating this with a null because that's how like strings are stored in memory. So the next thing we want to do, because we are like allocating just next to where the malloc hook is like we want now to allocate the malloc hook function with the address of system. So we want a size of like 24 bytes. Yeah, so that will be okay. The next thing we want to do is like we won't use malloc this time. We like just do this like p dot send line, we want that to be 1, then p dot yeah, and then you are like doing that. So basically what this is, it's like the address of where our bin.sh is. So this will like call system and then pass bin.sh as the argument in RDI. We get an error, so we want to like define what GLIBC is first. So we like need to do that, and then you can say like the puts address. libc.symbols.puts, then that will like be it for now. Yeah, and you can see that it's also complaining that the int object has no attribute encode, so let's change that to a string. Yeah, and you can see it's now working, kind of working. So let's debug that. Let's first set like GDB to off, then let's see. We get a shell, so yeah. The next thing we can like try to do is like search for the bin.sh like manually, like not manually but using like the helper function. So that will be like this, can like call this like cmd equals to and then you can like call this into like we want this to be cmd. Yeah, and we get into a shell again. Okay, see you next time.